national attention. And in case we have forgotten, because we keep hearing that 2014 has been the warmest year on record, I asked the chair, you know what this is? It's a snowball. And that's just from outside here. So it's very, very cold out, very unseasonal. So here, Mr. President, catch this.
2018 was the warmest year on record. Before that, it was 2017. Before that, 2016. Before that, 2015. And then 2014. A pattern like this cannot be a coincidence. Yet, there are many people that do not trust this evidence. So let's look at what global warming and climate change are and their consequences. Let's start with global warming. Here you can see the average land temperature of the Earth during different years. You can see that this temperature is changing over time. Similar charts can be made for ocean temperature and atmospheric temperature, and they show similar trends. The temperature is rising. One way to better understand how a variable of interest is changing is to compare it to a reference value. You can define different references, but the general trend is not debatable. The temperature anomaly, which is the change in temperature compared to the reference temperature you have, which you take from one of these years, is growing. Now, a lot of people, like that congressman that I showed at the start of the video, seem to not understand that here we are not talking about the average temperature over the whole world, not the temperature in a certain locale. A certain place might face colder temperatures than ever, but the whole world is getting warmer. And we see why this is important in a second. So overall, there is an increase in the mean temperature of the Earth's surface, a global warming. From basic science, we know that temperature is a measure of the energy within a system. So where is this extra energy in the Earth system coming from? To understand this, we need a model of the Earth. In science, you can define different forms of systems. Earth is a closed system. Heat and other forms of energy can be interchanged with what is in space, like the sun, but the total mass of the Earth is almost constant. Of course, in reality, there is mass changes, for example, when you launch something to space or when the atmosphere degrades, but these are very small compared to the total mass of the Earth system. So if the temperature of Earth is changing, then we should be trapping more of the sun's heat than we did before. Our studies show that the total energy we are receiving from space has not changed that much, so the source should be a change within the Earth system. And this brings us to the greenhouse gases. Gases whose impact in the atmosphere is similar to the glass making the walls of a greenhouse. They trap the energy in. Water vapor is a greenhouse gas, so we will always be generating some of these gases like water vapor. The issue is balance. As a closed system, Earth has mechanisms to keep the different greenhouse gases in balance. Plants grab carbon dioxide from the air in their process to generate nutrients. Greenhouse gases generated by decomposition of animals and plants are trapped in the soil, etc. So what has changed that has kind of affected this balance? Well, humans happened. We get those decomposed animals and plants in the form of oil and gas. We burn them, making more water vapor and CO2, and pump it into the atmosphere. We are also changing the surface of Earth, affecting other elements of the system. As the temperature increases year by year, the ice in many locations on Earth, including the poles, has melted. And this has led to more trapping of heat. The melting ice increases the sea level as well, and the amount of seawater that can evaporate to form clouds increases, and these clouds themselves have an effect on the energy balance. Then, as the temperature of the soil is increasing, gases such as methane trapped in the soil get released and add to the effect, and this cascading snowball effect continues. Now, nature always has a buffer, a system which dampens the effects in the short term in the hopes of stabilizing it. In our body, we have buffers to control acidity of the blood and other parameters, and in nature, we have buffers against things like excessive warming. Buffers generally work based on this principle, which is called the Lucia Toliets principle. which basically says that a system that is in equilibrium or is balanced will react to any stimulus in a way to maintain its equilibrium. So if we push the system in a specific direction, for example, we try to increase its temperature, it will push back through some mechanisms within it. But the buffer is also designed to react to small natural changes. Human-induced effects are not natural, and as we can decide to react to the buffer's effects, we can kind of push the buffer beyond its limit and make the system go out of control. And we see these effects on the Earth ecosystem as well as it reacts to human-induced global warming. A good example of this is climate change. In the past few years, the number of extreme weather phenomena has dramatically increased. Heat waves, sudden downpours are becoming stronger and more frequent. In addition, localities are also seeing changing weather patterns where a locale that used to be hot and sunny at a specific time of the year is now seeing rain or snow, which is something new for them. So all of these effects, going from our effect on the environment to global warming to climate change, is exactly why the Paris Agreement under the United Nations Framework Convention on Climate Change, or UNFCCC, was put together to put a limit on global greenhouse gas emissions in order to reduce the climate change effects. The reality is that we do not really know how the Earth system works as a whole, so we cannot take action against things that we don't really understand within it. What we can do is control the part that we do understand and know about, the greenhouse gas emissions. The choice is ours. We can push the buffer to its limits and destroy the whole system, or we can try to prevent it from reaching the point of no return by taking actions on things that are in our control. And of course, it might be too late to take action, but at least if we take action and we fail, we've tried. Otherwise, we might need to find another planet to live on, which unfortunately we cannot do yet.